Welcome to the Electric Power Engineering Centre of the University of Canterbury. The EPECentre is all about promoting the education of electric power engineering and electric power engineering research. In this short video, Professor Pat Bodger will show us the high voltage lab facilities at the University of Canterbury.
I'm Pat Bodger. I'm a Professor in Electric Power Engineering in the Department of Electrical and Computer Engineering at the University of Canterbury. I've been here for about 30 years. I started as a lecturer and have worked my way through and been head of department. In 2003 I started the Electric Power Engineering Centre. I've done a lot of research in power systems analysis, but currently it's on energy analysis and modelling, appropriate technology development and also high voltage. This is our high voltage laboratory. It's the only one in a university in New Zealand. Here we can generate 1.4 million volts of a lightning impulse, and we can also generate up to 300,000 volts of mains frequency AC.
Now, the University of Canterbury is the only university in New Zealand who has such a facility, and this sets us apart in being able to provide an outstanding degree program in electrical and electronic engineering and for those who specialise in electric power engineering. One last point to make before Pat shows us these facilities is that from the New Zealand industry there is high demand for graduates who specialise in electric power engineering.
Here we can create flashovers, we can create sustained arcs, and we can even liven you up in our Faraday cage. But really this is about teaching students the fundamentals of high voltage and electric fields. We can see things here which you can't see out in the real world. Example of a new type of transformer we're developing. It's a superconducting transformer and operates at liquid nitrogen. Over here we have a new experiment looking at heating logs for export. They need to be disinfected before they're put on ships, and this is using high voltage electricity to do that. This apparatus here is our lightning impulse generator. It generates up to 1.4 million volts, and it's used to testing equipment that goes out into the field and might be subject to lightning impulses. This is our Faraday cage. It's made of metal so that when you step inside you can be elevated up to high voltage and you're completely safe. Over here we have what we call the ash house. It's a project that's investigating the contamination of suspension insulators with volcanic ash. This is something which knocks out transmission lines every now and again when we have a volcanic eruption. The sphere gaps. These are used to measure high voltage under lightning impulse or mains frequency. We get a flash over from the top sphere down to the bottom. This bit of apparatus is for demonstration purposes. Put high voltage across the two rods and it creates an arc across here, and then the heat of the arc makes the arc rise and disappear out the top. And once it does that, it restrikes here and carries on. It's known as a Jacob's ladder. For electric power engineering, the high voltage laboratory gives our students a unique experience. It's a very practical one, and it underpins the fundamentals of the power systems that they're going to work with.
Such a degree specialisation leads to a satisfying career and many career choices, one of which, for example, might be working for a power company and ensuring the reliability of electricity supply to New Zealand homes and businesses. This is something that's crucial for the New Zealand economy.